Okay, so here are your notes for today. This is Thursday, September 16th. Sorry I'm not there, but I'm sure you're doing just fine without me. So I'm going to have you guys take these notes for adding and subtracting and scientific notation, and there's going to be a practice page to go along with it. So first we'll start out with adding and scientific notation. This one isn't quite as easy as multiplying and dividing. It's not terrible, it just requires a little bit more work, and I know how you all love work, so this is going to be a good fit, yeah? Sure, Mrs. Marsh, whatever you say. Okay, give me 1 second to set up my station here, because this is not, this glare, you guys know how I battle this glare all the time. Okay, adding and scientific notations. So we're going to have our first example, 4.6 times 10 to the third plus 8.72 times 10 to the fourth. Okay, so what you're going to do here, we're going to have some steps. So step 1, you guys love when I have steps. We're going to convert the values to standard form. It's not as simple as just adding these numbers and then doing the multiplication here. That's not how it works. You can't do that because they have different exponent values. You have to actually turn them into their number form. So I would take 4.6, and I'm going to move my decimal 3 places. And I would add it to 8.72, and I'm going to move my decimal 4 places. So now I have these two values. Cool, cool. And my step 2 is to line up the place values and add. Okay, so I have 87,200 plus 4,600. It's very important you line up the place values. If you had the 4 under the 8, you're going to get an extremely different answer, and I don't want you guys to make mistakes just because of that. So now I add these up, and I get 91,800. And then step 3 is to convert back to scientific notation, which I know you guys all can do because we've practiced that plenty, right? Convert back to scientific notation. I'm sorry that that's kind of hard to read. So I would write the 91800. I'm going to put my decimal here, and I would count 4 loops to the right. So my final answer is going to be 9.18, I don't even have to have the zeros, right? Times 10 to the fourth. Okay, so that's how you have to, let me see if I can fix this so you guys can read it better. There we go. I know this is not ideal. Okay, so that's how you have to work these out. Step 1, again, is to change the values into standard form. Step 2, line up the place values. So make sure that you have all the ones, the tens, the hundreds, thousands, 10,000s lined up correctly. And then you convert back into scientific notation for your final answer. So let's try another one. We don't have to write out all the steps, but we're going to follow them. So I have 5.6 times 10 to the 7th power plus 1.2 times 10 to the 3rd. So I'm going to write out the values in standard form. 5.6, I'm going to shift 7 places. Plus 1.2, and I'm going to shift 3 places. And so now I'm going to add them up. I've got a 5, a 6, and then 6 zeros. And then I have 1,200. Again, making sure that I line up the ones, the tens, the hundreds, and thousands. So now I've got this long number. But remember, the last step is to change it into scientific notation. So I'm going to put my decimal here. 1, 2, 3, 4, 5, 6, 7 loops. So my final answer is going to be 5.60012 times 10 to the 7th power. Remember, I have to show all of the digits up until I just get zeros. So I have to have this 0012 as part of my answer. Okay, let's move on to example 3. Here we go. We've got 4.6 times 10 to the negative 4 plus 5.36 times 10 to the negative 6. So we're going to do the same steps. We're still going to move the decimals. This time we're just going to move them to the left because I have negatives. So I've got 4.6. I'm going to go 1, 2, 3, 4 plus, and I'm going to scoot this down here so I have plenty of room to move this 6 places to the left. 5.36, 1, 2, 3, 4, 5, 6. Fill in my 0 placeholders. I'm going to line up the place values again, right? This one's a little bit easier because I'm just going to line up the decimals. This is where you're going to want to make sure that you're writing your numbers the same size so that you don't have one row that's bigger and takes up more space. I'm going to go ahead and put some 0 placeholders here just for visual aesthetic, right? It helps to make sure that I'm adding them correctly. So I'm going to get 6, 3, 5, 6, 4, and then I'll have 3 zeros. And just like with the first 2 examples, I cannot leave this in standard form. I have to change it back into scientific. So remember, we put our decimal here after the first non-zero digit. We count that it would take 4 loops to the left. So my final answer is going to be 4.6536 times 10 to the negative 4. And this is a negative because I had to go to the left. Okay, so that's adding. Now we're going to move on to subtraction. So subtracting in scientific notation. Nice little clouds there. So we're going to do the exact same steps. As adding. So I'm not going to write out all those steps again because I have them here. If I need to, I can look back at step 1, step 2, step 3. So step 1, remember, is going to be to convert into standard form. So I've got 3.5 times 10 to the negative 2 minus 6.6 times 10 to the negative 3. So I'm going to take the 3.5 and I'm going to move my decimal 2 places to the left, minus, and I'm going to have my 6.6 and move my decimal 3 places to the left also because it's a negative. So now when I subtract, I'm going to make sure I have the place values lined up. And you absolutely cannot rearrange, right? You can't rearrange a subtraction problem. So do not rearrange. in business here. I've got some spikies. A spiky cloud. Is that what we want to call it? I don't know. All right, so I've got 0.035 minus 0.0066. I'm going to put my 0 placeholder here. Notice that my numbers are lined up, right? I've got my tenths, my hundredths, my thousandths, my 10,000ths. So I'm going to put a 0 placeholder here so I don't forget, because you can't do 0 minus 6. You have to borrow. So this turns into 4, this turns into 10. I can't do 4 minus 6, so I have to borrow again. So now I have 14 minus 6 and get 8. Bring down the 2, bring down the 0. I have to put it into scientific notation, so I have a decimal that goes between the 2 and the 8. I would have to go 2 loops to the left. So my final answer is going to be 2.84 times 10 to the negative 2. So yeah, it takes a little time to convert and subtract and convert back, but it's not difficult. It's just taking the time to do it. So we have one more example. Let me grab another piece of paper. Okay. So this one we have is 7.8 times 10 to the 7th power minus 2.45 times 10 to the 6th power. So I'm going to make sure I move my decimal 7 places to the right because this is a positive exponent. Minus, and I'm going to take my 2.45 and move it 6 places to the right. Fill in my 0 placeholders. This is where it gets a little crazy because I have to make sure I line up my place values, right? So I've got the 7, 8, 0. So I'm going to have 6 total zeros. And then what I'm going to do is I'm going to start with my zeros from this side. I have 4 zeros. And then I have my 5, my 4, and my 2. So that way I make sure that they line up all the place values. I'm subtracting these. I have to do some fancy business borrowing, right? So first I have to take from this, then this turns into 10, then it turns into 9, and then this turns into 10. 10 minus 5 is 5, 9 minus 4 is 5, 7 minus 2 is 5. That's a lot of 5s, and then I just bring down this to 7. And the last step, remember, is to convert back to scientific notation. I have 7 loops. I went to the right, so my final answer is going to be 7.555 times 10 to the 7th power. So when you start this practice that you're about ready to get from Mrs. Reynolds, I need to see this whole process per question. Okay, no funny business, no using your calculator, right? I need to know that you can do this without a calculator. So when you are practicing the adding and subtracting, I need to see that you converted it, so you're going to need a separate piece of paper. I need to see that you converted it to standard form, you wrote out the problem, and then you converted it back into scientific notation. Okay? All right, thank you. Have a good day.